This is Chapter 4, Wireless. Wireless media is often referred to as unbounded media, which means the path for network transmission is unrestricted. When copper core or fiber optic cable is used, the transmitted network signals are bound to the medium. When the atmosphere is used, the transmission is spread throughout the atmosphere and is not limited to a single path. Electromagnetic waves are categorized according to frequency ranges. For example, common radio waves used for communications start at 0.5 megahertz for AM radio and span to 22 gigahertz for satellite communications. The frequency of an electromagnetic wave is based on the repeating pattern of its waveform. One complete waveform is called the cycle, and frequency is the number of times a cycle occurs in 1 second. Electromagnetic waves are produced both intentionally and unintentionally as a byproduct of electrical energy. Radio and television stations produce electromagnetic waves intentionally, while many household appliances produce electromagnetic waves unintentionally. Unintentional electromagnetic waves are referred to as interference, or more specifically, noise. Radio and microwave transmission works on the principle of producing a carrier wave as the means of communication between two wireless devices. A carrier wave is an electromagnetic wave of a set frequency that is used to carry data. It is identified by a frequency number. The carrier wave is mixed with the data signal. The mixing of the carrier wave and the data signal is known as modulation. A simple radio broadcast consists of a transmitter, which generates the carrier wave and modulates the information into the carrier wave, and a receiver, which receives the modulated wave and demodulates it. The transceiver and receiver must both be at or very near the same carrier frequency wave for communication to occur. The bandwidth of a carrier wave is referred to as a channel. Technically, a channel is a small portion of the electromagnetic spectrum and is used to designate a set of frequencies for a particular electronic application. The FCC assigns channels and bandwidths for electromagnetic waves. Radio interference is interference that matches the frequency of the carrier wave. The Federal Communications Commission, FCC, is responsible for dividing the entire electromagnetic spectrum to prevent electronic equipment from interfering with one another. However, this is not always possible. Many different devices use and produce electromagnetic waves. Virtually any type of electrical equipment can produce radio interference, even if it is not assigned to the radio frequency spectrum assigned to wireless LAN communications. There are two major classifications of antenna that are associated with radio wave and microwave-based wireless networks: omnidirectional and directional. Omnidirectional is the transmission of electromagnetic signals in all directions, while directional is the transmission of electromagnetic signals in a focused or aimed direction. The omnidirectional antenna is a straight piece of wire. The wire is engineered to match the exact length or fraction of length of the frequency's wavelength. Matching the antenna length to the wavelength of the radio frequency ensures the best possible reception and reduces the possibility of picking up interference. The omni antenna is typically used for a wireless transmitter to broadcast in a 360-degree pattern. The dipole antenna is one of the most common radio antennas used. What makes it popular is it's relatively inexpensive to manufacture when compared to other antennas. The dipole is commonly used as a client or receiver antenna rather than as a broadcast antenna. The dipole antenna is bidirectional, two directions. Rotating the antenna until the dipole aligns with the source of the radio wave transmission can enhance the reception. The Yagi antenna is used for point-to-point links. It is a directional type antenna. The Yagi antenna is typically designed from many radio antenna elements. Each element is progressively larger or smaller than the main element by approximately 5%. Some Yagi antennae are constructed inside a metal tube to further enhance the reception and transmission of electromagnetic waves. The flat panel is a directional type antenna used for point-to-point links. The antenna blends well in with building architecture and many times is very hardly noticeable. However, the disadvantage of a flat panel antenna is the consideration of wind load. Flat panels must be rigidly supported to reduce the effect of wind. Parabolic antenna is used for point-to-point links. It is directional, typically constructed from a grid of rods or mesh wiring. The parabolic antenna enhances reception by reflecting incoming electromagnetic waves with its curved surface to a horn receiver at its center. To communicate between radio-based wireless network devices, several transmission techniques are used. There is single frequency, which is the simplest. There is spread spectrum, and there is orthogonal frequency division multiplexing. A high data rate not only relies on how fast the data can move between 2 points, but also on how much data actually has to be retransmitted because of interference. Transmission techniques divide an allocated frequency band into many separate frequency ranges or channels. Spectrum is a transmission technique that uses multiple channels to transmit data, either simultaneously or sequentially. The term spread spectrum refers to transmission channels spread across the spectrum of available bandwidth. And the spread spectrum technique, data can be transmitted on multiple channels simultaneously or sequentially. The spread spectrum technique that transmits data on multiple channels simultaneously is called frequency hopping, and the spread spectrum technique that transmits data on multiple channels sequentially is called direct sequencing. Frequency hopping Frequency hopping is also referred to as frequency hopping spread spectrum, or FHSS. Frequency hopping is used with wireless devices that use 2.4 gigahertz radio band. The 2.4 gigahertz frequency is a bandwidth of 83.5 megahertz. Rather than use the entire range as a single channel to carry radio data, the frequency band is divided into 79 1 megahertz channels. Instead of transmitting the data packets over a single channel, the data packets hop from one channel to another in a set pattern determined by a software algorithm. Direct sequencing is also referred to as direct sequencing spread spectrum, or DSSS. It divides the 2.4 gigahertz frequency band into 11 overlapping channels of 83 megahertz each. Within the 11 channels are 3 channels with a 22 megahertz bandwidth. The 3 channels do not overlap and can be used simultaneously. Using 3 channels at the same time results in higher data rates than frequency hopping. The data rates for direct sequencing are 11 megabits per second and 33 megabits per second. The 33 megabits per second is a result of using all 3 22 megabits per second channels at the same time. Which brings us to the last technique, the orthogonal frequency division multiplexing, or OFDM. This transmission technique is used with wireless devices that use the 5 gigahertz radio band, and it can achieve a data rate as high as 54 megabits per second. The OFDM transmission technique divides the allotted frequency into channels similar to frequency hopping and direct sequencing. Orthogonal means separate side by side over a range of values. In wireless application, the term orthogonal means there are multiple separate radio channels side by side within an assigned radio band. Frequency division means to divide the assigned frequency range into multiple narrow sub-frequencies. Multiplexing is an electronics term which means to combine content from different sources and transmit them collectively over a single common carrier. By combining the 3 terms, OFDM means to communicate wireless data over several different channels within an assigned frequency range. However, in OFDM, each channel is broadcast separately and is referred to as multiplexed. While not required, most wireless networks contain a wireless access point, or WAP, also referred to sometimes as just an access point, or AP. A wireless access point provides a connection between a wireless network and a cable-based network. The typical WAP comes equipped with two omnidirectional antennas. One antenna is used for transmitting and the other is used for receiving. This allows for full duplex communication, which makes the WAP more efficient than if a single antenna were used. When a single wireless access point is present in a network, all communications must go through it. You can think of a wireless access point as a traffic director for packets. The access point controls the flow of all packets on the wireless network. When multiple wireless access points are used, the roaming device, whether it's a laptop or a tablet or whatever, automatically detects and connects to the access point with the strongest signal, which is typically the closest access point. All wireless access points in a wireless network typically use the same service set identifier, or SSID. The SSID is similar in nature to a workgroup name or domain name. It is the name that identifies the wireless access points in the same network. Usually, multiple wireless access points within the same network would be configured with the same SSID to support network roaming. When separate network systems are within range of each other, the wireless access points for each separate network should use a different SSID to distinguish themselves from one another. A wireless network that contains more or than one or more wireless access points is normally arranged in infrastructure mode. When a wireless access is not present in a wireless network, it is arranged in ad hoc mode. The reference to the term ad hoc means that the system is put together rapidly and usually intended to be temporary rather than permanent. An ad hoc network can contain a maximum of 20 computers. Typically, an ad hoc network consists of a laptop and a desktop talking together. An ad hoc network can be compared to a peer-to-peer network where all the devices are equal. Radio wave-based networks adhere to the 802.11 standard. The 802.11 standard consists of four, possibly five classifications: 802.11a, B, G, N, and currently coming online are AC. AC is simply one classification, not two. 802.11 network devices are often referred to as a Wi-Fi, which stands for wireless fidelity. The use of the term Wi-Fi was more due to manufacturers forming the Wireless Ethernet Compatibility Alliance, or WECA, in an effort to standardize wireless network devices. Very quickly, 802.11a is a standard that operates in the 5 gigahertz frequency, has a maximum data rate of 54 megabits per second. 802.11b was developed at the same time as 802.11a, but it was the first to be adopted by industry. It has a maximum data rate of 11 megabits per second. 802.11g followed A and B. 802.11g operates in the frequency range of 2.4 gigahertz. This makes it downward compatible with 802.11b devices. When communicating with 802.11b, the maximum data rate is reduced to 11 megabits per second, but it normally operates at 54 megabits per second. 802.11n operates at 5 gigahertz and is backward compatible with the 2.4 gigahertz range. In 2009, the Wi-Fi Alliance organization ratified a standard based on a draft version of 802.11n. An N device is compatible with A, B, and G, but may not support the MIMO technology, or MIMO technology. That's multiple input, multiple output, which only works when it's using the N standard. Basically, the MIMO technology uses two or more streams of data transmission to increase data throughput and the range of the wireless network. Transmitting two or more streams of data on the same frequency channel is referred to as spatial multiplexing. 802.N incorporates the multiple input, multiple output technology using 5 gigahertz and 2.4 gigahertz frequencies with an expected data rate of approximately 300 to 600 megabits per second. Two other global wireless standards that are out. 802.15 is known as Personal Area Networks, or PAN. It basically includes Bluetooth and some other smaller standards. 802.16 is a standard called Broadband Wireless Access, better known as BWA, or Wireless Metropolitan Area Networks, WMAN. This project was concerned with connecting LANs to each other using wireless technologies. The working group is hoping to design data rates as high as 70 megabits per second over distances of 30 miles or more wirelessly. Wireless technology can be cost effective as compared to cable-based network media when spanning long distances or when installing, say, a temporary network or a network in a location that would be cause a lot of remodeling if you were having to put in wired. Wireless technology is most appropriate for mobile devices like laptops, tablets, etc. However, there are certain wireless technologies that are affected to a various degree by atmospheric conditions like rain, lightning, fog, and sunspots. But the greatest disadvantage or concern for wireless technology is security. Network signals are transmitted in the open air and are capable of being picked up by unauthorized receivers. A network infrastructure should be designed to use, network infrastructure that is designed to use cable are inherently more secure than wireless networks. To combat this security problem, 802.1x is a draft standard for authentication methods for wireless networking. It is referred to as a draft standard because it is not complete. The 802.1x draft standard provides a means for a client and server to authenticate with each other. Authentication is typically achieved through the exchange of a username and password based on the Extensible Authentication Protocol, or EAP. EAP. The Extensible Authentication Protocol is used for both wired and wireless network systems. EAP ensures authorized access to the network system and network resources. The improved version of EAP is called PEEP, which represents protected EAP. 802.1x includes encryption as a standard, which is a way to hide the contents of network packets. Since the packets are broadcast through the open air, anyone could capture the packets and inspect the contents using a protocol analyzer or packet sniffer, such as Wireshark. A wireless network encryption key is used as part of the mathematical algorithm to encrypt data that is to be transmitted over a wireless network. So those are the two things provided in 802.1x, authentication and encryption. The very first type of security that came out of this was WEP, or Wired Equivalent Privacy. You can see by its name that the Wired Equivalent Protocol is intended to make a wireless network as secure as a wired network. It used encryption, but not authentication, and it is now considered completely hackable and obsolete. Use it if you can possibly avoid it. WPA, which stands for Wired Protected Access, is an improvement to overcome the weakness of WEP. It uses the most desirable features of Temporal Key Integrity Protocol, or TKIP, which is part of a 802.11i standard. TKIP improves wireless security by constantly changing the security key rather than leaving it the same for all the packets. WPA PSK is a variation of WP, where the PSK is a pre-shared key, in other words, a password. It was basically designed for small office or home office networks. WPA2 is an improved version of WPA. It uses the Extensible Authentication Protocol, or EAP, for authentication. It is also based on the 802.11i standard. Main difference between WPA and WPA2 is the fact that WPA2 has stronger encryption. It uses the Advanced Encryption Standard, or AES. WPA2 is backward compatible with WPA devices. For the most security on your wireless network, you should use WPA2. As always, remember to keep calm and document everything.